Okay, today is February 28, last day of class in February. Congratulations. You're going to be March here soon. But don't forget, in Minnesota, March is actually the snowiest month. but it's going to be warm, so if there is any snow, it'll probably just melt off really quick. It'll be a little bit like Colorado is all the time. You get snow, but it just melts away. All right, where is 5 pi over 4? Well, the more important question to start with is where is 1 pi over 4? So 1 pi over 4 would be there. This is 2, 3, 4 pi over 4. That's how to count it up. Okay, so 5 pi over 4 is right there. And then you draw your triangle, and hopefully you know that pi over 4 is the same as 45. So then you know it's a 1, 1 root 2. Now, I know if you wanted it to be in the unit circle, you could make it more complicated by dividing everything by the square root of 2. You don't need to do that. You need to be careful, though. See if anybody forgot their negatives. We'll find out soon. Okay? And now, sine is opposite over hypotenuse, and therefore negative 1 over root 2. What if they forgot the negative? Take off half of a point. All right. Who in here just marked that right? Raise your hand if you did. Okay, good. On to number 2. And by the way, by marked it right, I actually don't want you to do anything if it's right. You just leave it alone. All right, number 2, tangent of pi. Well, we're very close to the same area. I'm going to redraw the circle here. And here's where pi is. And then for this kind, you want to say this is at negative 1, 0. And then you got to know what sine, cosine, and tangent mean. Okay, so what does sine mean? It's the y. If I'd asked for sine of pi, it would have been 0. If I'd asked for cosine of pi, it would have been negative 1. But I asked for tangent, and that's the y over the x. Is 0 over 1 even legal? Yes, it is. So the answer is 0. If they said undefined, they are wrong, and they're going to lose the point. 0 divided by 1 is okay. It's 1 divided by 0 that's not. All right. And number 3, 11 pi over 6. Well, that's really close to 12 pi over 6, so it's really close to being all the way around at 2 pi, but not quite. Okay, and that's one where you have a 30-degree angle. So then it's a 30, 60, 90. I didn't take my own advice on this one. I made it too long and skinny. I'm going to try to keep my own advice going. Try to always make them nebulous enough that you could believe that these angles could be 30 or 60 or 45. In this case, they are 30s, and so this is a 1, and this is a 2, and this is the square root of 3. But what about the negative? There we go. And now cosine is adjacent over hypotenuse. In this case, that negative wouldn't have burned you because it's adjacent and hypotenuse, and it's root 3 over 2. Okay, on to the next one, number 4. There's 2 answers for this one. This is your hint that there's 2 answers. Now, if there's a 0 answer and a 2 pi answer, that's the same thing. I want to get you used to this. Generally speaking, if you have a choice between 0 and 2 pi, which one is simpler? 0. So that's what you should pick if you're picking between them. Because sometimes it won't even allow 2 pi. It'll be like that. Less than 2 pi. So don't use 2 pi if you're picking between 0 and 2 pi. All right, in this case, it didn't matter because cosine is negative. So where is cosine negative? In 2 places. That's why there's 2 answers. Okay, so all students take calc. Cosine's negative. Well, easier way to say it is cosine's positive here and here, so it can't be there. And therefore, cosine's negative in these 2 spots. And then cosine adjacent, hypotenuse, and then this must be 1, 2, square root of 3. And then I can try to think about what angle this is that's across from the square root of 3. Or another way to say it is, across from the 1 is where the 30 should be. So that's a 60. But it's not really a 60. We want it to be radians, so we're going to say pi over 3. But the answer isn't pi over 3. It's 2 pi over 3. That's one of your answers, 2 pi over 3. And the other answer is in this quadrant. And notice, I'm not going to have to recreate the wheel. I already know that the answer has to do with pi over 3's. So I'm going to say this would be 3 pi over 3, and this would be 4 pi over 3. Don't have to recreate the wheel. 2 pi over 3 and 4 pi over 3. What if they have one of the 2 right? Give them half. Any questions so far? How many have grading a perfect paper so far? All right, awesome. And last but not least, number 5. Where is sine negative? Well, there's actually two places, but they said to use quadrant 3. So then that's this quadrant. So then I'm going to focus on that one. Sine is opposite over hypotenuse. And then this would be 7, 8, and, I don't know, square root of something. And then I'd use a 64 and a 49. 64 minus 49, which is square root of 15, right? Okay, but don't forget that it's negative. All right, so negative square root of 15 on that side. And then I want the cosine of it. Cosine is adjacent over hypotenuse. Here's the adjacent. Here's the hypotenuse. Negative root 15 over 8. I think that's it. Then give them a score out of 5, but then immediately scale it up right next to it to a score out of 10. So if they just got 4.5 out of 5, they just got a 9 out of 10. So give them both scores. That makes it really clear which ones. Sometimes if you get a 4, it's like 4 out of 10, sadly. But so figure out their score out of 5 and their score out of 10, and then put a little CB in your name. CB Hans Christian Andersen, whatever your name is. If you're as famous as Adele, you can just use a first name. All right. Head back to your spots. So if there's people that are absent for today's quiz, obviously you could get all the answers right here on the video, so I'm not going to have you guys redo this quiz. If you were absent today, you are excused from the quiz. So let's move on to what are we doing in today and then Monday. Big picture, test is Tuesday. It's pretty much reviewing, but we're going to have a little lab experience with Skittles. And then I had one more thing to show you today. And this is still obviously a little bit of a review for the test. So, okay, so what's one thing that we didn't talk about in our little practice quiz there that you still are supposed to know? You're supposed to know about arc length and radians. And so if I gave you an arc of a circle, here's a super simple one because it's a quarter of the circle. Then obviously it'd be 1/4 of pi r squared. Do you remember the formula though? Theta r was the arc length formula, the SOAR formula. Would you use that? And if this radius is 10, would you please figure out the arc length then? Don't say it, write it. You should be able to do this in radians because you should be good enough at that now. And I know it's 1/4 of the area of the circle. You could do that for the area, but this is the arc length. Arc length is a different formula. It's that little distance right there. Pausing for a second while you try that one. And in fact, I know there's some kids already done with that, so I'm going to give you the last one, which is, do you remember the days of the space shuttle? And we would launch the space shuttle out into space to service the International Space Station and that kind of stuff. And basically, it had this huge booster, and it kind of rode on the back of that. And then once it got up into outer space, it kind of looked a little bit like a plane. But the space shuttle was brought out to the launch pad by this thing that was incredibly slow. It was incredibly heavy, and so it needed to just go super slowly, brought it out to the launch pad, and then stopped. Okay, so that thing would roll like 3 feet per minute. Would you please figure out what that is in miles per hour? It's obviously less than a mile per hour, right? If you're only going 3 feet per minute. It's way less than a mile per hour, but would you please figure out exactly what it is in miles per hour? Pausing for a second, we try those 2 problems. Okay, so there's so many kids that are absent today. I'm actually making the call right now. I'm gonna move that Skittles day to we'll do that on Monday because there's like 5 kids absent, and I want them to have a chance to do that. So this is 10. This is 10. This is 90, but you shouldn't think 90. You should think pi over 2. Why? Because this formula only works if you do it in radians. And this is pi over 2 times the radius, which is 10. So then that simplifies down to 5 pi. That feels kind of like an angle, but it's not. What is pi really? 3.14. So 5 times 3.14 is about 15, or since it's a little more than 3, it might be like 16 or so. But this is the exact answer. It's 5 pi. Raise your hand if you had that for the arc length. Okay, and then last but not least, 3 feet per minute. First of all, the way I wrote it was deceiving. You should really put this. That way you have a fraction and you can multiply it by other fractions that are facts. If I wanted miles per hour, I don't have miles or hours. So I got to multiply by some things. 5,280 should have been on the bottom. Why do I know it's on the bottom? Because the feet need to cancel. And this will be 1 mile. Then I got it in miles per minute. Okay, and then I'm going to get rid of minutes because I want hours. So minutes has to go on top, so it'll cancel with the other minutes. What's the fact I know about minutes? 60 minutes, 1 hour. Do I have it in miles per hour now? Yes, I do. You'd have 3 times 60 is 180 divided by 5280. Okay, so that'd be 180 over 5280, and that's in miles per hour. That is a very small fraction of a mile per hour. It didn't have to roll very far. It basically just had to come out of the hangar and out to the launch pad. So it could go slow and it was fine. Okay. So now we need to talk about, have you ever heard of secant? How many of you have heard of secant before? Okay, good. Do you know what it is? All right. So there are 6 trig functions. So far, all we've been doing is sine, cosine, and tangent. I get to tell you what the other ones are, and they're so easy because they're just a reciprocal of one of the ones you know. So in other words, if I, for instance, know that sine, everybody write this one down, of theta is 1/2. By the way, you should have this one memorized by now. Sine of what is 1/2? 30, also known as pi over 6. Might as well memorize that one. It comes up the most. Not even close. Sine of 30 is 1/2. If you needed to, you could always draw yourself a 30, 60, 90 triangle. In fact, I'd like you to do that off to the side. Let's make a 30, 60, 90, 1, 2, square root of 3. And do you see why the sine of 30 is 1/2? If you have that triangle memorized, we may as well have it there. Okay, so this is my way of showing you all 6 of the trig functions. I'm going to move this down a little bit so I have room. Move this up and above it. And now, if sine is 1/2, what's cosine? I've got my triangle there. It's going to be easy to tell. Cosine of that same angle, which really is a 30. Okay, cosine of that same angle would be root 3 over 2. And last but not least is tangent of that angle, TOA, opposite over adjacent. None of that is new. That should not be groundbreaking material there. Does that all make sense to you so far? I don't want to mess this up. If I've screwed up a number, please tell me. I think I got them all right. Okay, then let's move on to what are these sister functions, the ones that go together. Sine, I don't like to start with sine, actually. I like to start with the cosine one. The one that goes with cosine is secant. So I'd write it right across from it, and sometimes call these the flippin' sisters, because the answer to this is just the flip of the original. 2 over root 3. That's all there is to it. Just flip it over. Now you guys know the SOHCAHTOA thing, right? Okay. Sine is opposite over hypotenuse. Cosine was CA, adjacent over hypotenuse. And so then what is secant? Hypotenuse over adjacent. Very good. And then That's right. Tangent is TOA, opposite over adjacent. Okay. Sine, cosine, tangent. Now, we've got secant. I'm going to use black to keep the symmetry going here. Across the top from sine is cosecant, but it's CSC. That's the three-letter abbreviation for it. Don't think too hard. These are the flippin' sisters. What do you think it is? 2 over 1. Let's just put the over 1. I know 2 over 1 is 2, but we want to keep the consistency of seeing it's just flipped over. Okay? And last but not least is the tangent. And anybody know the last function that I haven't told you yet? Nobody in the room even knows what it is? All right. I'm going to say them in order, and I bet you'll be able to fill in the last blank. There's sine, and there's cosine. There's secant, there's cosecant. There's tangent. Maybe I didn't emphasize it enough. There was sine and cosine. There was secant and cosecant. Okay, there's tangent and there's cotangent. There you go. Those things are called cofunctions, but we abbreviate with 3 letters, COT. And I think for a long time, some of you guys thought that sine was just a 3-letter word. It's not. It's an abbreviation for SINE. And cosine is COSINE. And tangent is TANGENT. And these are just 3-letter abbreviations. Okay, so cotangent of theta is flippin' sister, technically called reciprocals. Flip it over, 3 over 1. And you've learned so toa, but did you know cho shakao? Now, it's not the greatest because you got your C and your S, and you got another C. Uh-oh. Here we always had 3 different letters, S, C, and T. Okay, but here we have C, S, and another C. So it'd be really hard to keep them straight. So it's not like I'm going to have to fight too hard on this, but I would not recommend memorizing cho shakao because it doesn't actually work that well because you got 2 C's. Can't tell if it's cosecant or cotangent. That's the ho versus the ow. Okay. So, what does this mean? This means, remember that little quiz I just gave you a second ago where I had asked, like, what's sine of 5 pi over 4? I can also ask you, what's the cosecant of 5 pi over 4? It was really not that hard. You just flip it. So, here, if I was asked for the cosecant of 5 pi over 4, everybody, you just did this a minute ago, and you were able to do it just fine. So do it again. Where's 5 pi over 4? It's there. And then what do? You draw a triangle. And then this is pi over 4s are the same as 45. So this is 1 square root of 2. Be careful with the most common mistake in circle trig, which is negatives. And then you're all set up to do it. But this is the part where I would refuse to do it. This is like nonviolent resistance. I would say, Mr. Server, I refuse to do cosecant of 5 pi over 4. Sorry, I won't do it. What? What are you talking about? Because I would rather do the sine of 5 pi over 4, and then I will reverse it. You get what I'm saying? Just do the sine of 5 pi over 4, which is opposite over hypotenuse, which is negative 1 over the square root of 2. And then do you get that you can change this and flip this, and you'll have your answer. I'm going to change this to cosecant of, notice the angle does not flip. And I'll flip this. And the negative, it doesn't matter where the negative is. I should really just like put it in the middle, neutral ground. So what's the cosecant of 5 pi over 4? Well, what's the sine of 5 pi over 4? And then flip it. This actually isn't just a hack. Does your calculator even have a secant button? It doesn't. Because they didn't want to clutter up the calculator with a whole bunch more buttons. Because do you get, if you're going to do secant, you're really going to do cosine, and you're just going to flip it. All right. So let's see. I gave you help on that one. Everybody figure out what secant, remember what its sister is, of 11 pi over 6. Figure out the secant, 11 pi over 6, and I'm fine with you saying, I politely refuse, Mr. Server. I'm not going to find the secant of 11 pi over 6. Instead, I'm going to pause for a second while you give that a try. Okay, so on this one, the student drew the triangle in the right spot, and then they didn't actually find secant first. They found cosine of that angle, and then they just flipped it over and got that. Raise your hand if you had that one right. Awesome. That's all there is to it. It's not that hard. All right, one other thing, and this is just an intro. You're going to use this a lot more in another chapter, but if that's x, and that's y, and that's 1, I told you how that tells us what sine and cosine are, right? So what's sine again? Sine's y. So then would you agree I could, if I put a theta here, write sine over here and cosine right here? Somebody tell me something smart involving sine, cosine, and 1. Sine over cosine isn't equal to 1. Sine over cosine would be tangent, but somebody tell me something that involves the sine and the cosine and the 1. Come on. Say that louder. Equals 1. Yes. Cosine squared plus sine squared is equal to 1 squared, but that's just 1, right? A squared plus b squared equals c squared. That is the first of what are called identities. Identities is a whole different chapter. We're going to have a whole chapter on this stuff. Where things that, just looking at that on its face without the picture, you'd be like, I have no idea what you're even talking about. But when you see the picture of it, it's not that hard, is it? It's just like the side of a triangle. It's a right triangle, so a squared plus b squared equals c squared, so it's not that bad. But then that leads to other craziness, like, do you get that we just learned a second ago that cosine has a sister function? The thetas are angles. You have to have a theta in there. It doesn't make any sense. The little squared, I don't know if you're noticing it's a small thing, but I could have put it like this and said squared, but the shorthand way to square it is to put the squared after the cosine. Why don't you think they put the squared there? Because it looks like the angle is being squared. And it's not. It's the cosine of the angle that's getting squared. Okay, so then, you just learned a second ago, the cosine has a sister. What is cosine's sister? Okay, so then I could put 1 over secant there if I wanted to. All right. And I could replace sine with 1 over cosecant if I wanted to. Now, here's the one that's more common, though. Would you agree if I wanted to, I could multiply by anything I want, because this is an equation. I can multiply by anything I want, as long as I do it to both sides. Okay. Would you also agree I could divide by anything I want, as long as I do it to both sides? So then, I'm going to choose to divide by cosine squared on both sides. And that's going to distribute to this one, too. And we get a new one. What is cosine over cosine? 1. Plus, what's sine over cosine? Anybody got this one yet? Tangent. And what is 1 over cosine? Secant. And thus you now find why people, even though we now know that tanning is bad for our skin, we still go to places and spray on tans, because the one with the tan is what you seek. Do you think spray-on tans will ever go away? All right. And then there's another one. If I divided, I'm going to save you some time. If I divided everything by, not cosine, but what do you think the other one would logically be to divide by? Sine. If you divided everything by sine, you would get cosine over sine, which is cotangent, plus the sine over the sine would be 1, would be equal to 1 over the sine, which is the secant. Sorry, cosecant, thank you. CSC. And in Minnesota, this is especially true. The one with the coat is cozy. It's dumb, but you're going to probably remember it. I'm not the originator of these, but I'm definitely the imitator of these. I like them. So these are called, well, they're called, there's a whole chapter on this. They're called identities. An identity is just a statement of truth, that this is this. Like, I am Mr. Server. That's my identity. I am that. Okay. Cosine plus sine, it is 1. It's just a fact. It is a statement of truth. And so you basically manipulate these statements of truth, and you can prove all kinds of interesting things. Because once you have statements of truth, you can say, like, I am smarter than... No, I'm not going to pick that. No, okay, I better not go there. I'm smarter than a walleye. How about that? That's going to be a safe one. All right. And a walleye is smarter than an amoeba. And therefore, I am smarter than an amoeba. Okay. That's just using statements of fact to, like, prove something. Okay. So you can end up proving statements of math using these identities. Okay, so let's get into your homework. The next thing that you need to know, everybody find the notes that are posted for today. It's 12.3 day 1. And it's the only day of it that we're going to do. Okay. You may have noticed that I am not focusing on having you memorize this unit circle, but I have been focused on you drawing those triangles. Whenever you need one, you just draw the one you need. So you can memorize this if you want to, and it would give you a little advantage in speed. But honestly, I know some of the teachers who teach AP Calc, which is where most of you are headed, and they don't emphasize using the unit circle. They emphasize you being able to draw triangles. Because this only works for 30s, 60s, 90s, and 45s. And what if the angle's different? Well, then it wouldn't work. What if the side lengths are different? Well, then it wouldn't work. Okay, so, I mean, it's useful. It's a cool thing. Just saying there's two schools of thought on this. And I am in the don't memorize that whole thing school of thought. And it's not just because of me. It's because I asked the people above this class, what do you want me to do? Do you want me to focus on memorizing that or not? And they said, don't focus on memorizing that. Okay, this is the one where I told you that secant and cosine are sister functions. They're reciprocals. All right, moving on. And this is just showing you that, you know, you can find the secant of pi over 6. But I said, just refuse to find the secant. Find the sister one, which would be cosine, because everybody knows how to find cosine of pi over 6. And then just flip it over. Okay, and this is where, let me see, do I actually want to start? Yeah, I do want to start. So I want to start right, I do want to start here. These are pretty easy, but let's just do, the last shall be first. do that one. Then let's do this whole row. No, I'm wrong. Cross off that whole row. Do this whole row. And this is the kind of stuff that's on the test, so we should definitely do these two. Challenger, as usual, those are things that are not required. So they're just getting into weird decimal angles that are really big, and so it's not that hard, really. All right, let's do number 29, and it says cotangent is root 5. Hint over 1. They just gave you two sides of a triangle. And remember, if you're not so familiar with cotangent, which I know, a second ago I asked the whole class what the last missing function was, and nobody knew. So don't tell me you're really familiar with cotangent. Okay? So then cotangent, I wouldn't use that. I would use tangent then, would be what? 1 over root 5. Then I'd draw my triangle. I've got two sides. I know where they go because I know what tangent means. It means opposite over adjacent. And it's in quadrant 3, so you can draw the picture for it, and then you can find the third side of it. And once, I've said this a million times, but it's true, once you have the triangle drawn in the right spot with all the sides written, then the actual question is super easy. What's the sign? It'll be easy once you have the triangle drawn in the right spot. You're just going to go opposite over hypotenuse. Be easy. Okay. There you go. Stay caught up on your homework. It really makes a difference. It really, really, really does. You have to believe that. Yes? No, I was suggesting that on the challengers, I was just giving you an example. They're saying that they're just making you do big angles that are decimals, and it's not that hard. But you do not have to do the challenger questions ever. Never a bad idea, but not required. Okay. Do that over the weekend. And Monday will be a review. Tuesday's test. Tuesday's the test. Yes, the lab is not really a lab, just to clarify. It is a 5-minute experience that involves Skittles. So. Do you get to eat Skittles after? You do. All right, and that's all I have for you for today.